Okay, so this is my first video on hybridization, and I'm going to start with sp3 hybridization. You'll notice that's a lowercase s, this is a lowercase p, and it looks like it's cubed, but we say sp3. So specifically, I want to talk about sp3 hybridization with respect to a methane molecule, and I'll draw a little methane up here in the top. Here's what I'm going to be explaining. The idea behind hybridization is that the atomic orbitals, specifically right now we're going to be focusing on the atomic orbitals of this central carbon atom, are hybridized into bonding orbitals. So think about what you remember from off-bow diagrams. I know it's been a while, but when we were learning how to fill out off-bow diagrams, we would have had, let's say it maybe started out looking something like that. And with carbon has a total of 6 electrons, 1s2, they would go in there, 2s2, they would go in there, and then 2p2. Remember Hund's rule, each electron gets its own orbital before they have to double up. Okay, these were the atomic orbitals for the carbon atom. They are hybridized, according to hybridization theory, into bonding orbitals. And here is the idea, that this s orbital and these 3 p orbitals combine together, and they form at an energy level that is higher than the s and slightly lower than the p, 4 bonding orbitals of equal energy. This whole idea of energy, if you remember back when we were first looking at off-bow diagrams, off to the side there was always an arrow pointing up that showed increasing energy as you went from low to high. These are 3 sp3 orbitals of equal energy. The 4 electrons that are in the s and the p orbitals in the carbon atom now each occupy an sp3 orbital that is used for bonding.
Here's what I found.
Okay, thank you, Siri. Go away. So here are the carbon valence electrons, each one occupying an sp3 orbital. The hydrogen electrons that are going to be involved in forming these bonds, remember these bonds are shared electrons, are going to come in here and bond with the carbon electrons. So there we have these 4 single bonds up here represented in these sp3 bonds of equal energy. Okay, let me show you another example of sp3 hybridization. Now remember, this sp3 hybridization for this methane molecule, the methane molecule itself is tetrahedral, and so we're going to, in the end, the main takeaway is going to be that whenever you have a tetrahedral molecule or a tetrahedral shape around a central atom like this carbon, you know that it is sp3 hybridized. Let me show you another example of things that are sp3 hybridized. This time, instead of a tetrahedral molecule, I want to talk about a molecule that is based on a tetrahedral arrangement of the electrons around the central atom. And specifically, what I want to talk about is, why won't that carbon erase? There he goes. Okay. What I want to talk about is, go back to black, ammonia. Here is an ammonia molecule up here up top. Now, if you remember your shapes, which you need to be working on, this guy is a trigonal pyramid. It's a 3-sided pyramid. But if you focus on the shape that's based on the areas of electron density around the central atom, generally it's based on a tetrahedral shape. So, in fact, we learned the bond angles by knowing that the bond angles for tetrahedral molecules are 109.5 degrees. The bond angles for this molecule are a little less than 109.5 because these lone pairs push them closer than they would like to be. Okay, this is also sp3 hybridized. Let's look at how. Let's go ahead and put out the off-bow diagram for a nitrogen atom. 1s2, 2s2, and I know it goes into the 2p's. Let me put my 2p orbitals over here. So 1s2, 2s2, and a nitrogen atom is 2p3. Okay, there we go. These are the off-bow orbitals for a nitrogen atom. Under hybridization theory, we say that this s orbital and these three p orbitals hybridize into sp3 orbitals that are all of the same energy. It is an energy slightly higher than the 2s and slightly lower than the 2p. And these 1, 2, 3, 4, 5 electrons that are the valence outer energy level electrons for nitrogen are in here. And by the way, they are filled in accordance with Hund's rule. You notice I went up, 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 down. Okay? So now I've got myself one of my sp3 orbitals, these hybrid orbitals, has 2 of the electrons from the nitrogen in it. The other 3 have a single electron from the nitrogen in it. And now the electrons that are associated with these hydrogens that are bonded in come in here. And these 3 sp3 orbitals represent these 3 up here, single bonds between the nitrogen and the hydrogen. The lone pair up here is these guys. Okay? That's sp3 hybridization. I'm going to talk about sp2 and sp hybridization, and then I'll give a summary as well.